Hi friends, welcome back to my channel. Today we will be looking at an exercise based on our previous lesson, which was velocity diagram. My name is Tsepo. Please subscribe to my channel to make sure you keep on receiving videos like this. Click that notification button so that you will be notified every time I post a new video. The question that we will do, it's a question extracted from a question paper which was written on 11 April 2019, and it is question number 5. It reads as follows. In a steam turbine test rig, a recorded quantity of 2 kg of steam per hour enters an impulse steam turbine at a velocity of 900 meters per second and is discharged through a nozzle inclined at 20 degrees to plane of rotation of the turbine. So far they have gave us the mass of the steam, which is 2 kg per hour, and they also gave us V1, which is the velocity of the gas as it enters the blade, and the value of it is 900 meters per second. And they also gave us the angle of the steam as it enters the blade. So we continue. The steam enters a series of turbine runner blades that are rotating at an average tangential velocity of 350 meters per second. That is the velocity of the blade, which is u, with each runner blade having an outlet angle of 32, and that is the outlet angle of the blade, which is phi. Take the relative velocity coefficient for the turbine system as the steam flow over the runner blades as 0.75, and that is the value of K. So before we continue to the questions, they have told us that we are dealing with an impulse turbine. And remember, from our previous lesson, we had 3 types of velocity diagrams. An impulse turbine, this is the structure of our impulse turbine, where we have our angles not equal, our triangles not being equal to one another. So we know that they have gave us V1. They also gave us the velocity of the steam as it enter, the outlet velocity of the blade. And then this at the end, this is how we are going. This is the structure that we should end up with. So we continue to the questions. Question 5.1, it says, construct a velocity diagram in the answer book on landscape to a scale of 1 centimeter is equals to 50 meters per second. That is the scale. Indicate all the angles and the velocity values in meters per second on the velocity diagram. No marks will be awarded for the velocity diagram or if the instructions are not followed accordingly. The instructions that they are talking about, it's the scale. You should follow the scale, and at the end of this question you should have this angle and this angle shown in your velocity diagram, and all the velocities that are found in the velocity diagram. And then this is these velocities that do not have values yet. So now we are beginning. We will begin constructing our velocity diagram. But first we should convert this according to the scale that they gave us. Our u, using our scale, is going to be divided by 50, and this will give us 7 centimeter. And then our v1, using our scale, is going to be 900 divided by 50, and this will give us 18, if I'm not mistaken, centimeter. And then from here we can start constructing. First we will measure this line, being the line representing our velocity of the blade, and we got that it is 7 centimeter. So we will measure 7 centimeter from here to here. That is our 7 centimeter. Then now I have the measurement of 7 centimeter. The next step to do is to measure these two angles, our 20 degrees and our 30 degrees. I will start with the 20 degrees. So this is our 20 degrees from here going that direction, and then our next angle, it's from here, this triangle, and it is 32. We measure 32. Our 32 is going to be something like this. Then now we draw the line. Then now we have our two angles. The next step from our given information is to draw this line, since we have the information of it. We know that the length of it is going to be 18 centimeters. So we measure 18 centimeters from this line. From this point going down, we want 18 centimeters. And then our 18 centimeters going to end here. So now all the given information we have used it. So now we have this line from here to here, and then we also have this point. So between this point and this point, we know that we get this line, which is VR2, and we do have this point, we also have this point. So our next step, we can just join these 2 points so that we are able to get VR1. So our next step is to join these 2. Just join from here to here, and then this is going to be our VR1, sorry. And then now we have this, we do not have this and this. We do not know the measurement of this line, but we know its angle. We do know it is going to be somewhere, the point is going to be somewhere here, but we don't know exactly where. And then that's where we will use this value, which is our K. There is the formula like this, which is VR2 is equals to K VR1. We already have this line, which is VR1. We have just constructed it. So our next step is to measure it. Measure this line. And I get that the line, it is 11.7. So we will say 11.7 using our scale times 50. And this will give us 11.7 times 50 will give us 585 meters per second. And then we come and put here the value of OK is 0.75 times 585, and then we get our answer as 0.75 times 585. It's going to be 438.75, and then we should convert this again to centimeters. We say this, our answer, divided by 50, and I got that my answer is 8.775. We can put that as 8.9. Yes, 8.8, sorry, so that we are able to measure it in our ruler. So this value that we got here is our VR2, this line. So we will measure 8.8 from this line, 8.8 centimeters. 8.8 centimeters. 8.8. 8.8, that's our 8.8. Yeah, our 8.8 will end here. And now we have this point, we also have this point. Our next job is just to join these 2 points and get our value of V2. So we will say from here to here, it's going to be V2. So I just joined these 2 points. Let me join them correctly. Yes, now it's good. And then we are done constructing our velocity diagram. The next step is to insert all the information that will be needed here. First we have to draw the velocity of flow and velocity of flow number 1 and velocity of flow number 2. So we said from here going down it will be 90 degrees. So we'll do something like this. Oops, I will have to move my camera because I'm running out of space. We will join this point, and it should be a point going upward and be perpendicular to that line at the top. And then we will say from this point we are going to do like this. This is our velocity of flow number 2, and then I will just do this from here. This is going to be our velocity of flow number 1. So now we are done with our velocity diagram. The next step is to just put the values, measure where we are supposed to measure, and convert using the scale that they gave us. So let's just first put the values that we know. We know that it is 350 meters per second. That is the value of U. This is 900 meters per second. Let me just say it's V1 meters per second. This is U. And then another one where it's, we know, this one we know is 32 degrees. This one we also know is 20 degrees. This we've already calculated it, and then we get that our VR, this is VR1, we got that our VR1 is, this is our VR, this is our VR2, our VR1 is this. So we put, this is going to be 585 meters per second, and then our VR2, we got that it is this. Our VR2 is going to be 438.75. And then what's next? We are left with this one, and this one, and also the wheel velocities at the top, which is this ones. So we will say okay, we'll have to measure VR2, our V2, it's going to be from here to here, and I got that it is 4.7, and then we will say 4.7 using our scale times 50, and I got that it is 235 meters per second. That is our V2. And then what's next? let's do our F, velocity of flow number 2, and then I got that it is also 4.7, which means this one is also going to be 235 meters per second. It's our V, velocity of flow number 2. So we go to this one, our velocity of flow number 1. I will measure this one, velocity of flow number 1, and I got that it is I got that it is 6.2, and then 6.2 times 6.2 times 50, we get that it is 310 meters per second. That's our V F1. Yeah, this is our VF2, VF1. And then almost done. We are going to measure our wheel velocities. We know that our wheel velocity, this number 1 is from here to here, which is from here to here. And then we're going to say from here to here. I got that my answer will be let me check. It's going to be it's going to be 16.9. So from here, oops, I'm sorry about that, from here to here it's going to be 16.9, and then this piece from here to here, I got that it is it's 5. From here to here it's 5. That's what? No, it's 0.5. 0.5. And then that will give us a total wheel velocity. Let me erase this. That will give us a total wheel velocity from here of 0.5 times 16.9. We'll have 17.4. It's going to be 17.4 times 17.4 times 50. It's going to be 870. This as our 16.9 times 50 will be 84 meters per second. Remember, they said the values in this diagram must be in meters per second. So this is our VW1, this is our VW, this is our V, the one that we're calculating from this side is VW2, and it is 0.5 times 50, and that would give us 25 meters per second. And then we are done with our velocities. The next values that we must find are the values of our angles, which is this one and this one. So the values of our angles, let's calculate them. Measure, not calculate, you must measure using a protractor. The first one, I got it as 32. As 32 degrees. And then the second one, I got it as it's 85. So this one, which is our beta, I got it as 85. degrees. And then now we are done with the first question. They say we must construct the velocity diagram and insert everything that they have asked us to do. This is everything that they said we must do. So you can go ahead now, since you are done, erase these things, because they were only here to guide us, and erase this so that your velocity diagram looks nice. And then yours should be cleaner than this, because this it's a mess. So because you will be doing for the exam, yours should be clean, not like mine. And then we go to the second question, which is 5.2. 5.2. Our 5.2, they say calculate the angle. They say use the diagram to determine the angle at which the steam leaves the turbine. The angle at which the steam leaves the turbine, remember, it enters and then it comes out. This is it. It's 85. And then next question. The inlet angle of the blade. The inlet angle of the blade, we know that it's in, and then it's in from that side, and then it's going out. This is the angle of the blade that they are looking for. It's 32. And then number 5.3, we'll do 5.3. They say use the diagram to calculate the power developed by the turbine. We know that the power is given by, it's equals to, to U V W. Oh, I should be M somewhere. Oh yeah, it's times M. I got my, no, this is the wrong formula. The formula for power is it's M times U times VW. This one's causing. And then our M, we know our M, where's our M? This is our M. It's 2 kg per hour. But because now we will be dealing with power, we know that always power is per second. We will say here divide by 60 times 60 times our U. This is our U. The value of U is 354 times our VW. Our VW, this okay, this is the value of our VW, and it is 870. So you see, it is very important that you do everything according to scale, because that value you have to use here. And then now when I do the calculations here, I got that my power it will be 169.167 watts. And then that is the end of our question. I hope this video will be helpful to you, and you have grasped everything that we did today, and everything is clear. So that's from me to you. I will see you on the next video. Ciao.